Pull out your phone right now and open the photo gallery. Scroll back 6 months. Find the picture of your car. Any picture. A trip you took. A parking lot. Something you posted online. Now zoom in on the tires. Look at the tread. Now walk outside and look at those same tires right now. You lost rubber. You can see it. 6 months of driving on the same 4 tires, and there is visibly less material between you and the road than there was in that photo. That rubber did not wear away because you drove too many miles. It did not wear away because you took corners too fast or braked too hard or forgot to rotate them on schedule. A percentage of that rubber disappeared because it was dying from the inside out the entire time it was mounted on your vehicle. Drying, cracking, oxidizing, losing elasticity at the molecular level every single day, whether you drove the vehicle or not. There is a $3 liquid that stops that process permanently. A liquid that triples the functional life of any tire on any vehicle by preventing the chemical degradation that the tire industry has understood, exposed, and exposed you to since the day vulcanized rubber became a commercial product. Big tire companies buried this because a tire that lasts 3 times longer is a tire you buy 1/3 as often. And a customer who buys 1/3 as often is not a customer. That customer is a threat. If you are not subscribed, subscribe and hit the bell right now. Because the compound name, the application ratio, and the full treatment protocol are in this video. The last time this was posted with documentation, it was removed from 2 forums and a video platform within 9 days. Every word from this point forward is the part they need you to never hear spoken this clearly. You replace your tires every 3 to 5 years. That is the number in your head. That is the interval your tire shop quoted. That is the mileage warranty printed on the receipt stapled to the bag they handed you when you walked out after spending $600 or $900 or $1,200, depending on what you drive and how badly the guy at the counter convinced you that the mid-tier option was not safe enough for your family. 3 to 5 years, 40,000 to 70,000 miles. That is what you were told the rubber is good for. And that number is accurate. Not because the rubber cannot last longer, because the rubber was manufactured to degrade on a schedule that guarantees it will not. Every tire on your vehicle right now is made from vulcanized rubber, compounded with chemical additives that determine how the rubber performs, how it grips, how it flexes, and how long it survives before the material begins to fail. Among those additives are antioxidants and antiozonants, chemical agents embedded in the rubber during manufacturing specifically to slow the oxidation process that causes rubber to harden, crack, and lose flexibility over time. Those protective agents are what stand between a tire that lasts 4 years and a tire that lasts 12. And the concentration of those agents in every consumer tire sold in this country is deliberately calibrated to deplete within the replacement window the manufacturer has determined is most profitable for their business model. That is not speculation. That is polymer chemistry. Antioxidant compounds in vulcanized rubber migrate to the surface over time and are consumed through reaction with atmospheric oxygen and ozone. The rate of consumption depends on environmental exposure, heat cycling, UV radiation, and the initial concentration loaded into the rubber during compounding. A higher initial concentration means a longer protection window. A lower concentration means a shorter one. The tire manufacturer controls that concentration at the compounding stage. They choose how much protection to build in, and they choose a level that ensures the tire degrades on schedule. In the spring of 1971, a polymer chemist named Edwin Hargrove was working inside a materials testing laboratory at a synthetic rubber production facility in Beaumont, Texas. The facility supplied raw rubber compounds to 2 of the 4 largest tire manufacturers in the United States. Hargrove's job was quality assurance. He tested the rubber compounds leaving the facility to ensure they met the specifications ordered by the tire manufacturers. Those specifications included antioxidant concentration levels, and Hargrove noticed something over the course of 3 years of testing that changed the way he understood the entire tire industry. The antioxidant concentrations specified by the tire manufacturers were far below the levels the rubber compound could accept. The rubber was capable of holding significantly higher concentrations of protective agent without any degradation in performance, grip, or structural integrity. Hargrove ran his own tests on the side. He compounded sample batches at elevated antioxidant levels, 2.5 times, 3 times, and 4 times the concentration specified by the manufacturer. He aged the samples in accelerated thermal and ozone exposure chambers that simulated years of real-world environmental degradation in a matter of weeks. The results were not subtle. Samples compounded at the manufacturer's specified concentration showed significant hardening, surface cracking, and elasticity loss at the equivalent of 4 years of environmental exposure. Samples compounded at 3 times the specified concentration showed no measurable degradation at the equivalent of 11 years. Same rubber, same polymer base, same reinforcement chemistry. The only variable was the amount of antioxidant loaded into the compound. The rubber did not wear out at 4 years because rubber wears out at 4 years. The rubber wore out at 4 years because it was given exactly enough antioxidant to last 4 years and not a month longer. Hargrove documented his findings in an internal report and submitted it to the facility's technical director. The report included complete compound specifications, accelerated aging data, and a cost analysis showing that the additional antioxidant loading required to triple tire service life would add less than 1.40 per tire at the manufacturing stage. The technical director read the report, met with Hargrove privately, and told him that the antioxidant specifications were set by the customer, not by the facility. The tire manufacturer ordered the concentration they wanted. The rubber supplier filled the order as written. Hargrove asked whether the manufacturer was aware that higher concentrations would dramatically extend tire life. The technical director told him that the manufacturer's polymer engineers understood rubber chemistry at least as well as anyone in the building. The conversation ended there. Hargrove's report was filed internally and never forwarded to the tire manufacturers. He left the facility in 1974 and spent the rest of his career in industrial polymer applications unrelated to the automotive tire market. But the chemistry did not leave with him. Antioxidant and antiozonant compounds are not proprietary secrets locked inside tire factories. They are standard industrial chemicals available through any polymer supply distributor. And the principle Hargrove documented that externally applied antioxidant compounds can be absorbed by cured vulcanized rubber and restore the protective chemistry that has depleted through environmental exposure was already understood by every polymer chemist working with rubber in any application. Throughout the 1970s and 1980s, industrial maintenance operations that relied on rubber components began applying external antioxidant treatments as standard practice. Conveyor belt operators in mining and aggregate processing treated their belts with antioxidant solutions to extend service life in high UV and high ozone environments. Heavy equipment operators treated hydraulic hoses and rubber suspension bushings. Agricultural operations treated implement tires on tractors and combines that sat in direct sun exposure for months between seasons. The treatment worked across every application because the chemistry is universal. Vulcanized rubber absorbs antioxidant compounds from external contact the same way it releases them through surface migration and oxidation. You can put back what the atmosphere took out. The rubber does not care whether the antioxidant was loaded during manufacturing or applied after curing. It absorbs it, it uses it, and it stops degrading. The consumer tire market generates approximately $80 billion annually in the United States alone. The global tire market exceeds $230 billion. Those numbers exist because tires are a recurring purchase. You do not buy tires once. You buy them every 3 to 5 years for every vehicle you own for your entire driving life. A family with 2 vehicles spends roughly $100 to $600 to $400 on tires every 4 years. Over a 30-year driving life, that household spends between $12,000 and $18,000 on tires. A treatment that triples tire life does not trim that number. It collapses it by 2/3. That same household spends $4,000 to $6,000 over 30 years instead of $18,000. The $12,000 difference does not evaporate. It comes directly out of the revenue of every tire manufacturer, every tire retailer, every tire installer, every tire disposal operation, and every alignment shop that sells you. A tire rotation package to make you feel like you are extending the life of a product that was manufactured to expire on someone else's schedule. No industry generating $80 billion annually allows a $3 treatment to reach consumer awareness when that treatment eliminates 2/3 of total replacement demand. That is not a theory. That is the operating math of a business model built entirely on the assumption that your tires will need replacing. At intervals, the manufacturer determined before the rubber was even poured into the mold. Now here is what you were never supposed to understand. Your tires are dying 2 separate deaths simultaneously, and the industry only talks about one of them. The first death is tread wear. Mechanical abrasion from contact with the road surface removes rubber material gradually with every mile you drive. Tread wear is visible. It is measurable. It is the death your tire shop talks about because it is the one that sounds inevitable. The second death is oxidative degradation. Atmospheric oxygen and ozone attack the polymer chains in the rubber, breaking them apart, causing the material to harden, lose flexibility, and develop surface cracks that propagate inward over time. This is dry rot. You have seen it. The sidewall cracks, the small fissures between the tread blocks, the brownish discoloration on a tire that has been sitting in a driveway for 2 years. That is oxidative degradation, eating the rubber alive from every exposed surface. Dry rot does not require miles. A tire sitting in a garage, losing air once a month, is being destroyed by oxidation at nearly the same rate as a tire driving 15,000 miles a year. And here is the part that changes everything. On the majority of consumer tires replaced in this country, oxidative degradation reaches unsafe levels before tread wear reaches the minimum depth. Your tires are not wearing out. They are rotting out. You are replacing tires with usable tread left on them because the rubber compound has degraded to the point where the tire is no longer structurally safe. And the reason the compound degraded is that the antioxidant protection built into it at the factory was calibrated to expire years before the tread wore down to the replacement threshold. The $3 liquid reverses that equation entirely. Here is the protocol. The compound is a liquid antioxidant and antiozonant solution sold under industrial product descriptions, including rubber conditioner, rubber protectant concentrate, and elastomer antioxidant treatment. The active ingredients on the label will include one or more of the following: paraphenylenediamine derivative, commonly abbreviated as PPD or 6-PPD, dihydroquinoline-based antioxidant, phenolic antioxidant compound. These are the same chemical families used inside the tire during manufacturing. You are not introducing a foreign substance to the rubber. You are replenishing the exact chemistry the rubber was built with that has been consumed through years of environmental exposure. Purchase the concentrate from an industrial supply outlet, a rubber product supplier, or an agricultural chemical supplier. It is sold in small bottles and concentrated form. A single treatment for all 4 tires costs between $2 and $4, depending on the supplier and concentration. Do not purchase a consumer-labeled tire shine or tire dressing from the auto parts store. Those products contain silicone-based cosmetic agents that sit on the surface and block absorption of anything useful. They make the tire look black and wet for 3 days, and do absolutely nothing to restore antioxidant chemistry within the rubber matrix. They are the tire equivalent of the diluted fuel additives on the next aisle. Visible result: 0 functional benefit. Clean all 4 tires thoroughly before application. Use a stiff brush and a standard degreaser or all-purpose cleaner to remove all road film, brake dust, and any existing tire dressing residue from every surface of the tire. The sidewalls, the tread face, the bead area, the inner sidewall if accessible. The antioxidant compound must make direct contact with bare rubber to be absorbed into the polymer matrix. Any silicone residue or surface film from previous tire products creates a barrier that prevents absorption. This cleaning step is not optional. Skip it. And the compound sits on the surface and accomplishes nothing. Dilute the antioxidant concentrate according to the product instructions, typically a ratio of 1 part concentrate to 3 or 4 parts water. Apply the diluted solution to all exposed rubber surfaces of each tire using a foam applicator pad or a clean sponge. Saturate the surface. Do not wipe dry. The rubber needs sustained, wet contact time to absorb the compound into the polymer structure. Apply a heavy enough coat that the surface remains visibly wet for a minimum of 15 minutes. If the solution absorbs or dries within 5 minutes, apply a second coat immediately. Rubber that has been severely depleted of antioxidant protection will absorb the first application rapidly, because the polymer matrix is starved for the chemistry you are providing. Allow the treated tires to sit for a minimum of 4 hours before driving. Overnight is ideal. The antioxidant compound migrates inward from the surface into the rubber over time. Longer contact time before the mechanical stress of driving results in deeper and more uniform penetration. After the initial treatment, drive normally. Repeat the application once every 4 months for the first year. After the first year, reduce to once every 6 months. Each application takes less than 20 minutes for all 4 tires and costs under $1 in material. The antioxidant loading in the rubber builds cumulatively with each treatment. By the 3rd or 4th application, the rubber has absorbed enough antioxidant compound to resist oxidative degradation at levels that exceed the original factory protection by a significant margin. In 2016, a fleet maintenance manager named Tom Kettner, operating out of a regional delivery service in central Indiana, began applying this protocol to the tires on 18 delivery vans. The fleet operated in a high UV and high heat environment, with vehicles parked on asphalt lots during summer months when surface temperatures regularly exceeded 140 degrees. Previous tire replacement intervals on the fleet averaged 38 months. Kettner applied the antioxidant treatment quarterly to all fleet vehicles beginning in the spring of 2016. By 2020, the original tires on 14 of the 18 vehicles were still in service. Tread depth measurements at 48 months showed usable tread remaining on all 14 vehicles. Sidewall inspections showed 0 visible cracking or dry rot on any treated tire. The 4 vehicles that received replacement tires during the period required them due to road hazard damage, not wear or degradation. Fleet tire expenditure dropped from an annual average of $14,200 to approximately $3,800. Kettner documented the results in an internal fleet report, with photographs showing the condition of treated tires at 36 and 48 months alongside photographs of untreated tires from a comparable fleet at the same mileage intervals. The difference was visible from across a parking lot. The treated tires looked 2 years old. The untreated tires looked like they were ready for a landfill. Kettner submitted the report to a commercial fleet management publication for possible inclusion in their quarterly maintenance column. The editor responded that the content was interesting, but did not align with the publication's current advertiser relationships. The report was not published. A retired postal worker named Diane Olson Living in southern Arizona applied the treatment to her personal vehicle in the fall of 2019. Arizona is one of the harshest UV and ozone environments for tire rubber in the entire country. Her previous set of tires lasted 30 months before dry rot cracking on the sidewalls made them unsafe to drive. She applied the antioxidant treatment every 4 months, beginning with a fresh set of tires installed in October 2019. Those tires are still on the vehicle. As of the most recent inspection in late 2024, tread depth remains above 5/32 of an inch across all 4 tires. Sidewall condition shows 0 cracking, 0 discoloration, 0 hardening. 5 years on a set of tires in southern Arizona, on a vehicle that previously destroyed tires in 2.5 years. Olson posted her experience with photographs to an online vehicle owner community. The post was removed within 48 hours for violating community guidelines related to product promotion. She had not named a product. She had named a chemical compound. The post was not restored. The tire industry does not fear electric vehicles. Electric vehicles still need tires. The tire industry does not fear autonomous driving. Autonomous vehicles still need tires. What the tire industry fears is a driver who understands that the rubber on their vehicle was manufactured with a deliberate expiration built into the chemistry. A driver who understands that a $3 liquid applied 4 times a year restores the antioxidant protection the factory intentionally limited. A driver who fills their garage with tires that refuse to rot, refuse to crack, refuse to harden, and refuse to generate the replacement purchase that the entire $80 billion business model depends on. Edwin Hargrove proved in a Beaumont laboratory in 1971 that tripling the antioxidant loading in tire rubber triples the service life of the tire at a manufacturing cost increase of 1.40 per unit. The tire industry received that information. The tire industry understood that information. The tire industry set the antioxidant specification exactly where it needed to be to ensure your tires would degrade on the schedule that maximizes your lifetime spending on their product. The liquid costs less than a gallon of gas. The application takes less time than checking your tire pressure. The result is rubber that behaves the way rubber was always capable of behaving before someone decided your tire budget was more valuable than your tire life. You are no longer the person who walks into a tire shop every 3 years and hands over $1,000 without understanding why the last set did not last longer. You are the person who knows what antioxidant depletion means, what dry rot actually is, what compound reverses it, what it costs, where to buy it, and exactly how to apply it before you ever stand in that shop watching someone mount a new set of tires on rims that the old set should still be wrapped around. Subscribe if you are not subscribed. Hit the bell so the next video reaches you before it reaches a content flag. Share this with every driver you know who replaced tires that still had tread because the sidewalls were cracking. Every share is one more set of tires that stays on the road instead of sitting in a landfill generating profit for the company that built them to fail. The next video opens something they have kept quiet even longer than this. The coolant compound they reformulated in 1963 that eliminated the single most common cause of engine overheating, and why your cooling system flush interval has never once reflected the actual protection life of the fluid circulating through your engine block. You were never supposed to see any of this. Now you have. Drive accordingly.